Hi.
everyone. Hello everyone. Hello everyone. And welcome to another episode of Solving Advent of Code in Rust and trying to learn Rust in between. I'm Eugene and we have around us somewhere Luciano and Roberto.
Hello.
Hello, Roberto here.
Thank you for following along. If you never did Advent of Code, this is a challenge which is published every year in in the Christmas period in December. You can find things on adventofcode.com, which there should be a banner for right now. Hopefully, if I click the right thing. There are 24 challenges, one for each day leading up to Christmas. We publish all of our code on GitHub, and I will show that on screen right now. You're more than welcome to have a look there, submit PRs if you find a better way of doing things, or yeah, just comment if we do something weird. We're also publishing all the recordings of the Twitch streams on YouTube. You can find you can find the link to that in the description. And if you're watching this on YouTube, we stream this every Monday at 6 p.m. Irish time, which is, and you can find the link to that in the description of the YouTube channel. So last time we finished episode 13. Today we're going to do day 14, challenge 14. Luciano, can you share my screen so we can go through the README?
Yes, there you go.
Perfect. Thank you very much. So we'll start going through the description first, and then we'll go through the solutions in Python and Rust. So we'll read through the story a brief little bit. There's incredible pressures, and they're putting a strain on our submarine. And the submarine has a polymerization equipment that would produce suitable materials to reinforce the submarine. And there's nearby volcanically active caves that should have the necessary elements. So the submarine manual contains instructions for finding the perfect polymer formula, which is specifically a template, and a list of pair insertion rules, which is going to be our puzzle input. We just need to work out what polymer would result after repeating the insertion process for a few times. So this seems to be our input, where we get a random string and then some strings with arrows. The first line is the template, which is the starting point of the process, and the following section defines the pair insertion rules, like AB into C, which means when elements A and B are immediately adjacent, element C should be inserted between them. So these are basically a bunch of rules. Correct me if I'm wrong, guys, but we'll need to split each of these by the arrow, and whenever we find this pattern, we insert an element between the two letters, correct?
Yeah, exactly. Yeah, and the string will basically grow every iteration because we keep inserting one character in between every two characters.
Okay, let's have a look. I'm sure they have a little example here. Yeah, they do. Okay, so they're starting with the actual example they had up there, and then they follow the rules, and from NNCB, they got to NCNBCHB. Let's see what rules we had. So they had an NN, and they added a C in between them. They had an NC. Do we have an NC here? We do, and they inserted a B in between them. And then they had a CB, which should have a H between them, and it does. Okay, and then they went ahead and they added more for every pattern that occurred on the second iteration. Okay, the polymers grow quickly, fair enough. After step 5, it has a length of 97. Bloody blah. The most common, so taking the quantity of the most common element, B, which occurs 1,749 times, and subtracting the quantity of the least common element, which occurs 161 times, we get 1588. This is basically going to be the answer they expect from us.
Yes.
So we will get a template, we will get the rules for inserting things, we need to do it 10 times, and then we need to calculate the difference between the most common occurring element and the least common occurring element. Who wants to go first? Do we want Python or do we want Rust first?
I can show Python that.
I'd say let's also read part 2 because it should be fairly simple once we understood part 1, and I think it's easier to talk through the solution if we also know part 2.
Yeah, makes perfect sense. Okay, So part 2 says that the resulting polymer isn't strong enough. We need to run more steps. Okay, so a total of 40 steps should do it. This means we need to run it 30 times more. The most common element is B and the least common is H. Subtracting these produces a thing. And the ask is to apply 40 steps and find the most and least elements. What do you get if you take the quantity? So it's the same question, just run it more.
Exactly. Yeah, this is one of those advent of code exercises where it becomes like a complexity optimization problem because at part 1 is still manageable even with a brute force. Part 2 is like, okay, do it more, and at that point you probably need to figure out something a little bit smarter.
Okay, makes sense. Fair enough. Well, seeing how quickly it grows, yeah, I would assume that after 40.
Every step it doubles -1. So if you double,
Yeah,
starting from a bunch of characters 10 times is 2 to the power of 10, that is 1024, but to the power of 40 is way more.
Yep, and it just grows. And depending on the starting input as well. Now, this is advent of code, so we only get the one simple starting input. We could actually have a look at what the input looks like, right?
Yeah, and I can also take, this is the input, I can
We're
take the
starting
Luciano
with more.
ones because I have mines, because every advent of code has different inputs, so I can take Luciano inputs.
Yeah, copy them from the repo. We have a lot more rules, obviously, because we have a lot more input, so this is going to grow even more. All right, so we understand the problem.
And we have the starting string. In Python, I cheated, like Luciano pointed out last time.
Yeah, you already split it.
Did you share?
This first parse is done by...
Did we switch over to the Python, what's it called? Jupyter notebook thing?
Colab, yeah.
Cool.
We are there.
Can you make it just 1 point bigger, Roberto?
1 point bigger. This?
Yeah, that's more readable to me. Thanks.
Okay, perfect. So, like Luciano said, part 1 can be done in brute force. So part 1, I did it in brute force. I have a function called step that is taking a sequence of something, an dictionary of rules. Then is starting with just the first letter of the iterator, that in our case will be S, and S, we have to put it in the output. Then, for all the pairs, starting from the beginning and taking the letter after it. So we have the two lists. We take the first one, the list, and the list skipping the first one. We zip them together. So we have A and B. A will be the first character, B will be the second one, and then it goes through. We look in our dictionary of rules. If there is a rule AB, so SV, there will be, because advent of code is never giving us invalid input, but in any case is here, just to show the case that it is. I add to the output the letter that I found that goes in the middle, then the letter after that goes on the right, and then go through all of this for all the string that I have.
Okay.
Part 1 is this piece of code that is parsing the rules. So I split the rules by line, I split by the arrow, and I have a tuple, left, right. Left is the key, right is the value. My state is my start, that is this guy here. Then for 10 times, my state is the step on my state and the rule dictionary, and the dictionary of rules. When all of this is done, I will have a list of characters. I do a count. I use the counter from collection to count the letters. That will give me something like this, counter and numbers. Then I just return the max minus the minimum.
Easy peasy.
Let's see if it works with the Luciano input. I have to run the input paragraph. Now it's spinning up the remote Python. Okay.
I like the counter utility from Python. I don't know if there is something similar in Rust. We'll have to see.
Might be. Honestly, I'd be surprised if somebody didn't build something like it.
Now we have the counter with all the directors, and our result for part 1 is 3058. That from the README, I think, was correct, if I remember it correctly.
I think so. 3058, correct.
Yes, correct.
Good. Second part is a little bit more tricky. Why? Because like we said before, is way more stuff to do. I implemented the part 2 in 2 different ways, with a default dict and with a counter. Because we had a comment in some previous advent of code about why you use the default dict of integer instead of using a counter. And now I have the answer. Because default dict is faster. Because counter is doing a lot of stuff, like keeping track of the most frequent, the less frequent, and stuff like that we don't really need. We don't need to know what are the 5 top frequent letters, because we want minimum and maximum. So using counter, you are doing too many stuff. But again, we have we parse our dictionary of rules, same as before. We have part 2 that is implemented as a function called step. This time, I don't store the string because it's too big. So what do I store as my state? My state is a dictionary that is counting the couples of letters. To visualize this, I have a graph down here. Now I have to make it smaller of 1 point, because otherwise it's... So my start state is this, Sn, V, and whatever, with the number of letters that can appear. Those are the count of the couples that appear. Sn is showing up 1 time, and so on. After each step, the number of couples increase, new one pop up because we added the new letters, and so on. So if we have S and then, and S and then is there 2 times, and we have the rule that S and then goes to C, we will have SC that is incrementing by 2 times, and Cn that is incrementing again by 2 times. Same goes for MV. MV is resulting in, I don't know, something. Let's say that is resulting in A. So NA will be increased by 6 times, by 6. And AV will be increased by 6 again. Doing this, remembering not where they are, because we don't care where they are in the string, in our polymerization string. We don't care the position. We just care of the quantity. So in part 2, we remove the information about the position. That is not a useful information. Let's not keep it. Let's just keep the counters. And after you do this 40 times, now you see on the y-axis that the numbers are going up like 20,000, and here we are only at step 14. Okay, it's broken now.
Just a quick shout out while this is broken. Somebody in the chat, Villa MMH, did link to an actual counter in Rust. So somebody did do an implementation for it. Thanks for sharing that.
Okay. Yeah, if we have extra time, then we might try to install this crate and use it in our solution.
Okay, in the meantime, the Python animation broke for some reason. I'm trying to rerun it, but creating this kind of animation is a little bit time expensive.
By the way, let me rephrase your solution if I understood it correctly. So basically, we are saying that every couple of characters will spawn other 2 couples of characters at every iteration. So at the end of the day, we don't really care about keeping the real string that grows with things in the right place. We just count how many couples are spawned, and that will inform us how many will need to spawn in the next iteration, and we can repeat that as many times as we want. And at the end of the day, this way we are only keeping counters, and the total number of counters is the same as the total number of couples. Is that correct?
Yeah. So the step function at this point for part 2 is just taking a state. I also adding the counter because it's faster to keep incrementing the count of the letters while you go through, and is taking the dictionary of rules. So the new state is a default dict of integers. I take all the elements that are in the current state that are a couple of letters and a number. From this couple of letters, I take the letter J, that is the letter that I have to put in the middle of the couple. So it will go on the right of the first letter, and on the right of the first letter, and on the left of the second letter, and we'll create this new couple of letters as a key in the new state. How many of them? The value, because if we have 6, like I said before, if we have 6 of them, we have 6 of these plus 6 of those. Why plus equal and not equal? Because we can already find this combination for another reason, another couple that has a rule. For example, Sn become an A and Cn become an A. It means that An, you have to sum them in for both rules. And then here also we increment the letter that we found by V, by the quantity of these couple of letters. In the end, we return the new state. C is modified like a reference, so we are not returning C, is just modified as a reference. So we start with a state that is a default of integer. We populate it taking A plus B, same as before, from the start with all the stuff. We created the character counter that is this C, and we set it to 1 for all the characters that are in start, because we have to count even the start state. Then for 40 times we do our step function, our function called step, that is in updating the state, giving it back, updating this char counter using this rule. At the end, we return the maximum of the values of the counted chars minus the minimum of the values of the chars counter. Here, time it is to get an idea of the speed of this operation. Let's see if we have the same result as Luciano has in the README. If I go back from here, I can see the README somewhere.
Eventually,
I will reach a README. File 3447 330. Yeah, the number is matching, and this is the speed for this one. I did the same using a counter instead of using a default dict of integers. So the counter is used here to create the new state. Then you have to update it. What else? Is also used to count the characters instead of using a default dict of integers. Out of this, the result must be the same. Yes, it is. But if you see, it's taking way more. 1.7 against 0.2. Why? Because counter is doing way more stuff than just counting stuff. It's keeping track of the most frequent. So there is, every time you do an insert, there is probably an insert, sorted insert, and stuff like that. So it's doing stuff that we don't care about. In the meantime, does the graph computed and is now working? Yes. And if we go to the very end of this one, after 40 iteration, yes, we see that the most frequent was O, the less frequent was C. This is to the power of 10 at the power of 12, so a lot. And the most common, that we don't care, but just out of curiosity, the most common couple of letters is VO, with, again, a lot of them. So basically, part 1, trivial, you can keep the string. Part 2, not so trivial, so we had to discard the information about the position of the letters and just keep the information about the couples of the letter.
Nice.
Awesome.
Do we want to jump to the Rust solution now?
We can try, yeah. I'm gonna switch.
Just out of curiosity, instead of a default dict of integer, what did you use in Rust?
I think I did my own counter, but let's review, because I don't remember 100% that solution.
Okay, cool.
Okay, this should be up now. I hope it's readable. Let's make it 1 point bigger. Okay, so let's see.
I think it was readable even before.
Let's see. So we start with a custom struct called polymer, and this struct contains all the rules, character count. So yes, I'm doing my own counting. So it's just an AshMap that associates a character with a usides. And then segments count, which is similar, but is associating a couple of characters, so a tuple of 2 chars with a usides. Then we are implementing a from string on that polymer, and this is something we have done commonly to parse the input. So we just take the input as a string reference, str, and we just say into this polymer structure, and that basically does all the magic by running this function. So what this function does to parse the input is basically splits it, finding the 2 lines. So the first part is going to be the row sequence, the second part is going to be the rules. Then what we do, we start to allocate, stop highlighting, we start allocating the chars count. So we initialize the empty AshMap for counting the characters, and similarly we do the empty AshMap for counting the segments. The cool thing is that because AshMap implements default and both char and usides have default values, we can just use this thing, which kind of makes it the initialization the same for both of them. Then what we do, we say for every character in the row sequence, so this is our initial polymer, take every character, and then if that character doesn't exist, give it a default value. So the count that is going to be 0 because the default value of a usize is 0, and then increase that value by 1. So this way we are doing the first count of characters based on whatever is the initial polymer. Then what we do, this is actually something I wanted to mention because I saw that Roberto did exactly the same thing in Python. Because we need to read values 2 by 2, right? We need to read the characters that are close to each other in a window way, right? So the first two, the second and the third and the fourth, and so on. One trick that you did in Python, and it applies totally also to Rust, is that you do an iterator, then you clone that iterator, at least in Rust you have to clone it, but then you shift that iterator by 1, and then you zip both of them. So that way you are getting this view into the same data, but the first one is the regular one, and the second one is the one shifted by 1. And if you put them together, you're basically reading all the characters in couples of the first and the second and the third and the fourth, and so on.
Yeah.
So that looks like this. You just say chars will give you an iterator over all the characters. Then we clone this chars one. And by the way, this is quite cheap because we are operating like underneath, I think it's operating under references. So it's not really cloning all the data as far as I'm aware. Oh yeah, there is a suggestion here that we could have used Windows. I think I looked into that. This is something that we might keep for later. We might review this in the stream. But I think when I tried that was still unstable Windows, and there was a utility
I remember
from
something like that
from
because we wanted
Iterators,
to use
right?
We wanted to use that even for something else in another exercise. I don't remember what was doing. But again, there were to compare 2 or 3 stuff that were in sequence together.
Mm-hmm.
And so, and Windows was doing some magic trick to get the quantity of elements that you wanted to add.
Mm-hmm.
But there we had a problem because we wanted the last one to go with the first one because it was circular.
Oh yeah, there was another one, but I think the main issue is that it was a nightly feature to just use the default thing. Then there was another utility from Iterators, which is a third-party crate that you need to install, and I think we used that in some other exercise that was similar. So I think this is the like out-of-the-box solution that should work everywhere. But of course, it's not the nicest, right? You need you need to think a little bit about that. It's not just give me elements 2 by 2. So yeah, and then we do the zip. So again, this is exactly the same as Roberto did in Python. So once we have this zipped iterator, we get 2 characters at the time. And then what we can do is we say count the couples that appear. So we remember that we have 2 counts, a characters count and a segments count. So this second loop here is increasing the segments count for every couple that we find. And all of that is going to be our initial state. We also need to pass all the rules, which we haven't done yet. So again, what is a set of rules? Is an AshMap that associates 2 characters together with another character. And that literally means that these are the 2 characters that will make a couple, and you need to take the third character and put it in the middle to apply the growth rules of the polymer. So how do we parse all these lines? Again, we use split ones. We look for this particular string to decide the pair and the substitution. The pair, it's something that, again, we need to split character by character. So we get pair 1 and pair 2 are the first 2 characters that make that pair, and we use next and wrap to extract them from this chars iterator. And substitution is basically the right part of the arrow. Again, we just need to take 1 character out of it. I don't know if there is a nicer way, by the way, to do this. If you know it, let us know.
Because it's a string at this point, it's not a charter.
Yeah, because in Rust you always have to think that you are operating in UTF-8 strings. So a character is something that you need an iterator to extract it because it might be multiple bytes.
Yes.
So this is the way I know. I don't know if there is a nicer way to write it down, but this works. And of course, we can use unwrap just because we trust Advent of Code to give us a clean input. And we are not being too concerned with proper error handling. As far as I know, this is not recommended in production. It's better to always have at least an expect where you can say an error message. So if that panics, you get a decent error message. But even better if you actually handle errors with proper errors. So finally, when we get here, we basically have everything we need to insert a rule. So we can insert that particular rule, and that will continue for all the rules available. And at this point, we have all the rules we calculated here. Characters count we calculated at the beginning, and segments count that we calculated here. So that gives us the starting polymer. So this is all parsing and initial counting. Then the next thing that we implemented in this polymer is something that we have done before as well, especially with like game of life type of exercises, is every time that you have a game where you have to simulate rounds, so things change every round, and then you maybe need to simulate a certain number of rounds. In Rust, it's convenient to do that with an iterator because you write your logic inside that one iteration loop, and then in Rust you can just say instantiate the iterator and say take, I don't know, 15, and that will simulate up to the 15th iteration and give you the result.
Yeah.
And thank you, Willem. I'm glad that you like the approach with iterators. To be honest, I don't know if there are performance trade-offs, but my VS Code just suddenly crashed.
Oh, nice.
VS Code didn't like the iterator. Okay, so yeah, I don't know if there are performance issues. I don't expect so because Rust tends to be as zero runtime as possible. But it is nice because you get all the combinators with iterators. So, okay, how do you implement an iterator in Rust? If you've never done it before, it's actually quite simple. You need to say implement the iterator trait for your struct. Then you need to specify the associated type item. Now, in this case, first of all, what is the associated type? It's basically saying an iterator needs to emit objects or structs of a certain type every time you do an iteration. In our case, we don't really care because we just want to mutate the internal state. So that's why our item is literally the unit type, so an empty tuple that doesn't mean anything, because we are not interested in capturing a return from the iterator. We just want to advance the simulation. So this is maybe a little bit of a stretch for the iterator type, but again, it works nicely because you get all the utilities of iterators. Then the next thing you need to do, is implement next. And next is basically the logic that happens at every iteration. And next returns an option of that associated type. And the idea is that every time you try to advance the iterator, there might be a next element, or there might not be a next element if you reach the end of the iteration. So option is used to say, if you get a sum item, then it means that you are in the case where there is a next item. Or if you get a none, that means you reach the end of the iteration, and at that point, you can stop iterating. Okay, so now little disclaimer. Here I went already for the optimized solution because I actually spent a lot of time trying to make the brute force solution work also for the second part. And then, like an idiot, I realized that the scale was so big that it's not something you can brute force anyway, right? With today's computing, like it will take so much space that it doesn't make sense. And then I try to think more about a solution, and I come up with a solution that I think is going to be very similar to Roberto Python's one. So I'm just trying to count how many new couples will be spawned after every iteration and keep that count and spawning again at every new iteration. So this is why I have this new segments count. And it's an AshMap that associates two chars with a U sides. Initially it's empty. So now what I have to do, I need to take all the segments that I have in my current state, so in the polymer itself. So segments count, remember that it's like keeping track of all the polymers that are currently available in our polymer. And from that, I'm getting every single combination and the count of that combination. And I basically need to expand that combination by spawning more combinations. So for every couple, we will have a new element. which is basically what we get from that particular rule. So you take the two chars and realize what is the new char. Okay, there is a question here. Let me put it on screen. So I wonder if it would be faster to reuse the AshMap instead of making a new one each time. That's an interesting suggestion. So you're basically saying that this one, we move it, I guess, somewhere inside the polymer as part of the state of the polymer. And then in every loop, in every iteration, every call of next, we'll need to clean it up and repopulate it. We can test that if it's going to be faster. Let's keep this in mind for if we have time for exploring optimization. Maybe it could be faster because maybe it doesn't have to reallocate. So it's a good idea. I don't think if you delete items, it will deallocate, I guess, or resize. I don't know. We can test that assumption. Anyway, what I was saying is that for every combination, we find what's the new character, and that will generate two new items, right? Because we need to take this char, put this char in the middle, and then this char again. So we end up with this combination, 1 and 1, and this other combination, 1 and 1. So let's build those two combinations. So we first need to check, what am I doing here? Chars count, new element.
You are incrementing the chars counter.
Oh yeah, of this particular.
Because you can already increment it because you know that now you will have count character of that type more.
Exactly, yeah. So we remember that we need to keep two counters: the counter of couples that is used to respawn more, and the counter of characters, individual characters, which is something we need at the end to be able to answer the question. So that's why here we are incrementing the counter of characters, because we know this one will appear one more time, and we just add it here.
Count more time.
Yeah, where do we do the multiplication? I was expecting that.
Is that one the multiplication?
Oh, because it's just adding the count. Yes, that's correct.
Yeah.
So this means that at the moment we might have one pair or we might have n pairs. If we have n pairs, that means that this character will be repeated n times. So that's why we do plus equal count. Okay, now what are the two new segments? Two chars together in a tuple. The first one is the first part of the segment plus the new element. And the other one is the new element plus the second part of the segment. Because we have to insert the new character in the middle. So we'll have the left part and the right part. And new element is the new thing that is creating the two individual segments. So what is the new segment count? Is the same logic. Like this thing will be repeated count times. And this other thing will be repeated count times. So I am increasing the counter of both these new segments by count. And that's basically it. What I'm doing is I'm doing new segments count replaces the previous segments count. So in a way there I'm gonna, this is another case where maybe we can avoid overriding the object, might be more efficient, but it might also be a little bit more complicated. Here I'm just creating a new instance, populating it and replacing the previous one. And then at the end we just return sum of the unit type. The reason why we always return sum and never none, because in theory this thing could go on forever. So we could iterate as long as we want. So we don't really have an end condition. And I think that's it. Oh yeah, that's the interesting part. How do we find the min and max element? Here I implemented a custom function in the polymer type. And this is literally just scanning the entire set of values and keeping track of the minimum and the maximum. So in one scan, I keep track of the minimum element found, the minimum count found, the maximum element found, and the maximum count found. And as I go through every single item, if I find one that is smaller, I update these ones. If I find one that is bigger, I update these other ones. And at the end, I can just return the two minimum element and minimum count, maximum element and maximum count.
And is this faster than using give me the values min, give me the values max?
Good question. To be honest, you're right. I think I did this just for testing reason because I wanted to actually see the element.
Okay.
So maybe it's not necessary to do all of that, and probably doing that min max is just faster. this is another optimization we will try. Because in reality, let's actually look at the code. Like, this is all the utility functions that we have and structs. How do we use it? We take the input, we parse it into a polymer. Then for the first time, we just need to do 10 iterations. So we just need to take from 0 to 9. And at that point, we call the min-max elements. And as you can see, I am ignoring the actual letters here.
Yeah.
I just take the min and the max and return max minus min. This code is exactly the same, except we do 39.
Makes sense.
So that's pretty much it. Let's run the tests. Yeah, I think here I had some test where maybe I was checking. Yeah, here I was checking that the H and the B were actually the right ones. But to be honest, we could run the benchmarks, and if it's faster, we can change this test because we don't really care about H and B.
Yeah.
Yeah.
We just care about the value.
Exactly. Yeah.
Well, let's run a benchmark now.
So let's run all the tests first. Everything pass. If we want to run a benchmark, come on, give me a terminal. So CD year 2021, exercise 14, I think.
This
we
one,
can do cargo bench. So what did we want to optimize? We want to optimize for sure the min-max.
The min-max. There was a counter crate also.
Counter crate, yeah.
If it can be useful. And there was a third stuff.
Trying to reuse that AshMap counter rather than
not
replacing
relocate
it every iteration. Yeah, this is slow. Bear with Rust compiling.
Rust compiling is not fast.
Yeah, there is another useful suggestion here. That is checking how long different steps, like the parsing take, will be useful. I guess so. Yeah, we could. I would probably ignore the parsing, but the other steps, probably will make sense to do. We have something like a flame chart in the repository. So if you look at the repository, Roberto actually set up something pretty cool. Every time we do a change, it will produce a flame chart. So that's something we could look into as well. But I suppose...
I don't remember if it produces the flame chart if there is nothing in main, but we can take a look. I don't know. I don't remember.
No, so you're saying we should merge this, then make changes. And then
but we can try to see what the GitHub action is producing, because it's not commenting in the pull request, because I didn't find a way to add the SVG that is produced as a comment in GitHub.
Okay.
Because it can add images, but not SVG. And also is an interactive SVG, so probably security reasons.
Okay.
Makes sense.
So I'm producing the artifact. You can download it to your machine and open it locally with your machine.
So we can see here that part 1 is 115 nanoseconds and
micro,
is it micro?
Microseconds,
yeah. And second part is 520. So I would suggest we do one optimization at a time and see the difference. If we see an improvement, we keep that optimization. If not, we remove it and then we move to the next optimization.
Yeah.
I think a fast one to start with is the min-max.
Yes. Let me make this 1 point smaller. I think it's still readable.
Yeah, still readable though.
The min-max, we can basically just ignore this one, right?
We can return just a number.
Yeah, no, I think we can just say polymer dot. The two things all the things are private. So let's do another function for now. Let's just say result or solution, and it takes a self, it returns a useIds, and it does all the magic for us, right? So what it needs to do, it needs to go into the self.chargeCount and then get values and then get max minus self.chargeCount dot values dot min. And that looks awesome. Now, why you don't like it? Because could it be negative?
Yeah, it could be negative because it doesn't know.
I don't remember.
Return an e-size and we don't care.
That's true. And is it gonna be able to cast it? I think we need to say as isides and as isides. No? Clippy. What is it that you don't like? Non-primitive cast.
There is a mention that this way we do 2 loops, which is correct.
Yeah, but I don't know if it's faster or not.
One
I don't
way
know
to
how
find out.
smart is Rust.
Max returns an option.
Trying to figure out why
Max
doesn't
is
live.
returning an option.
Is it?
Yeah, probably min as well.
Oh, yeah. Then maybe we can just do unwrap.
Yeah.
Group point. I didn't realize, and it makes sense because if it's empty, there is no max and no min. Now let's see if it's still complaining with the minus. Probably it is because we can just return
Try
the
to return a usize now.
Okay,
Yeah.
cool. Now solution is not being used. What we can do here is just say polymer.solution and polymer.solution and run the benchmark again.
Yeah.
Is the benchmarking only part 1 and part 2, not the readme test? Yeah.
Only part 1 and part 2. We
Run
can
the
check.
test to see if it's still fine.
Yeah.
So this is
benchmarking
them. Okay, let's run the tests. Good point. I think this one will break the first test.
Oh yeah.
Oh, it didn't
No,
break.
because you didn't change the function. You create a new one.
Oh, yes. Good point.
So everything is
fine.
Run the
Actually,
benchmark.
we can also say assert EQ polymer.solution needs to be 1749 minus 161.
Yeah, good point.
Now, if this pass, we have a guarantee that we shouldn't have broken anything. Yeah, perfect. Okay, so let's run the benchmarks.
Cool.
By the way, thank you, Willem, for all the nice comments and suggestions. Keep in mind that we are still Rust noobs, so we'll do a lot of silly mistakes.
Yeah.
Okay, part 1 is actually slower, but just a little. Part 2 is slightly faster. Why?
Okay, noise on your machine, because 1% is not that much.
Yeah, and it's still around 500 and still around, what was the previous one?
100 and something, 20.
115 and 520. This is 117 and 509. So let's give it another shot just for fun. But I think it's pretty insignificant difference.
It's pretty much the same. It's just that it's way less code.
Yeah.
Fair enough, yeah.
I mean, it's easier to read.
Definitely, because I basically implemented my own custom min and max in one go.
That non-min and max are hard to read. Come on, it's something that you can read easily. But still is lines of code that in future you have to maintain. And
there is one more suggestion on calling the solution function loads of times for the for the benchmark, but that's what the benchmarking solution does on its own.
Yeah, we are using this crate called criterion, which should do all of that stuff for us.
Yeah, it's running the functions millions of times to get an idea.
Yeah,
thousands of times, because it's running the function.
Sorry, go ahead, Roberto.
It's running the function once, getting an idea of how fast it is or how slow it is, and then choosing a number of times to run it to get a benchmark.
So yeah, it is thousands, hundreds of thousands, who knows?
If that's what you mean. If you mean something else, please let us know in the chat.
Yeah, do let us know.
Okay, so this optimization, I'm actually going to keep it. So I'm going to remove all the other code because, as you said, it's more readable. So we basically get rid of more than 20 lines.
The test.
Yeah, we update the test. We remove this test here, which is not needed anymore. And let's check that we didn't break anything. Cool, all green.
Neat.
Brilliant. So what was the other solution?
The other optimization. Before going to the one not reallocating the AshMap, there was another one.
Counter.
The counter, great.
So basically new segments count. Oh yeah, I remember why I did this, because of course every time you do an iteration, because you insert things in the middle, you are changing the configuration, right? So next time you will have different segments. So that's why every time I was resetting, creating an entirely new configuration.
And you have to do that because you have to discard all the old one and create all the new ones. But still, probably it's possible to not allocate, but keep that in the state, just clean it, and then I don't know if it's making any faster.
We can try. And I think what we can do is something like we put here new segments count or next segments count. I just don't know then how to swap them.
You can keep an integer that tell you which one of the two to use.
There is a function called clear, is a comment we got again from Willem.
Oh,
But I
yeah.
just don't have idea if he's clearing even the memory allocation. At that point, it will be even slower, probably.
Maybe. We
Or
can
if
check
it
the
is
docs.
just saying, here there is nothing to see, but it's not deallocating.
Okay, let's do this one. So here is going to complain. He wants
Empty.
yeah, let's do it here next.
Default.
Apparently it keeps the allocation, so let's see.
Default.
What are you saying, Eugene? Sorry.
I was saying that, again, Willem, not myself, it keeps the allocation, so it should be faster. So fingers crossed, it's actually faster. That'll be cool.
Okay. So here we created it. So what we do here, we don't need to use this one anymore. We just need to clear the next, right? So we just need to say self.next x, come on, segment count dot clear, right? And then we allocate in next segment counts, right? So this is going to be self. This is going to be self.
Next, not new.
Next. Okay, and now here, how do we swap them? That's the thing. We need to swap the two things.
Yeah, segment count must become next segment count.
Yeah, I think there is a way to swap two items.
In Rust, we swap two references.
Don't know.
I saw something. My God, Tommaso show us something like that.
Okay, there are more suggestions.
Yeah.
So why not just use? Why not just do it in segment count?
Because we have to get rid of all the old couples and create new ones.
Yeah, because here we are iterating in segment count, so we cannot mutate the thing while we iterate it. Basically.
But also we can't. It's like the game of life. You have to create the new board without modifying the old board while you compute. Because if, for example, you have a couple that is SN, just one couple SN, and you want to insert the new segment will connect the new AshMap will contain no SN. It will connect. It will contain probably SO and ON that are two couples with the counter 1 and 1, but no SN that was the original one. So the original one is disappearing and the new one is appearing. But you don't have to do that in the same moment, because if you add, for example, ON even before, and then you create a new ON, going in splitting ON, you don't have to split the new counter of ON, but you have to split the old counter of ON. Otherwise, you are creating the wrong number of tuples, of couples of chapters.
Yeah, it's like you take a current snapshot and you build a new one of the previous one.
Like the board in all the game of life. You have the new one, you have the old one. You can't work in place because otherwise the new value will interfere with the old ones.
Exactly. Yeah. I like the suggestion of trying STD memory swap, and I think this is what Tommaso showed us one time.
Exactly. It was that one.
So we can
but I have no idea how it works.
Swap. Let's see. So what it has swapped the value at two mutable location without the initialize either one. So I suppose we can give it basically self.segment count and self.next segments count. Would that be it? And remove this one.
They must be mutable. And are they mutable or not?
Do they need to be mutable references? I think this works only with references, right? It kind of swaps the pointer, I suppose. So how do we deal with references without going crazy with lifetimes, I guess?
Lifetimes by enemy.
I mean, it's not the end of the world. What we can do is we could have like here an A, and here we do something like a current segments count. Current segments count is going to be an ampersand A of this. The ball, I guess. Is that the right syntax?
You lost me here.
Yeah, same.
When you start to have a reference of mutable with lifetimes.
Wait, let's remove this one.
It's too much for me.
So this one is correct. We don't have to say that the reference is mutable somehow. I'm not sure.
Oh, there were odds apparently. But we're told that we can make a mutable reference to them just by putting ampersand mute in front of it.
Yes, but you still need to put the...
Not here.
In the function itself.
In the memory swap.
Oh, okay.
Oh, we're in the memory swap directly. Yeah, fair. In the function call. Yeah.
So we keep this one as it is. We don't need to
Yeah.
change anything. I'm
Well,
not
let's
convinced
try.
about that, but let's try.
I mean,
So we just need to say ampersand mute.
no idea.
Yeah, apparently.
Oh yeah, that works. Awesome.
What is going to happen? A segmentation fault. I put my money on segmentation fault.
Okay, let's see. Let's see. I'm tempted to run a survey, but no.
Why not? Come on, do it.
Magic lol. Okay, let's run a survey. Let's see how many people bet on segmentation fault.
No, but it's impossible to have a segmentation fault in Rust. But
it's not impossible.
It's just harder.
It's just harder. I like your optimism, Roberto.
The whole point of Rust is having memory protection and not doing crazy stuff. Not going with pointers where nobody was going.
Start the prediction. Before. Cast your vote. Is it gonna burn on fire or Rust is gonna save us?
Or not work at all. Rust save the day.
How do I... Jesus, sorry. UI to Twitch is quite interesting.
I like the magic lol comment. Let's see if that's gonna be true. That is magic.
I can't... Well, I'm sorry, I can't vote apparently. Does this work?
I think because we are moderators.
Oh yeah, because I'm in the moderator view, you're right. Can I go back to the regular view and vote?
You have to create another Twitch account.
No, we're not doing that now.
Okay, nobody participated, so we'll find out. Let's see. Let's run the tests.
I tried.
What's going on? Yeah, all good. It's green, so it didn't go on fire.
Benchmark now.
So choose the outcome. Rust is awesome.
Nice.
Okay, now let's run the bench and see if this is awesome in terms of performance.
Yeah, it was the actual goal.
Yeah, in the very, very end, yes.
Sorry, my internet's acting up, so I have to keep switching tabs between the stream on Twitch and your actual screen.
It seems faster. 20% is not noise.
No.
Nice. Let's see the second part where it should have even a bigger impact. Well,
no,
21%.
It's the same because it's very linear with the number of steps.
Mm-hmm. Yeah.
True. Well, this is really good optimization. Thank you, Willem, for the suggestion. I'm really happy with it.
Committed.
I think we run out of time, and we could do the counter create next time, or
absolutely.
Offline.
So I'm gonna do the commit offline, and we can do the closing meanwhile.
Yeah. So... We'll wrap it up. Right. So, well, hope you enjoyed it. You can find the recording of this on YouTube if you joined a bit later, and there might be some weirdness at the beginning of it. Not sure of it. The link is on Twitch in the About section for the YouTube channel. If you're watching this on YouTube, we do live streaming every Monday at 6 p.m. Irish time. So depending on where you are, that might mean different things. Make sure you check the Twitch link in the YouTube description. Give us a follow so you can be notified when we post these things. Feel free to leave us comments or open PRs on our code. The GitHub repo is... Hang on, a little banner with it, unless Luciano already did so.
I did not.
You did not. Cool. So I put the wrong one on. Jesus, you should not let me be in charge of these things. Right, so you should have seen the banner pointing you to the GitHub. So yeah, everything's well accepted there. Like, we're trying to learn. Any pull request or any comment is more than welcome. Our solutions aren't going to be the cleanest or the most idiomatic, but we're hoping to learn and get better. So anything you can share is great. Thanks everybody for the suggestions today, for the collaboration. It was very good, and I think we're going to try to raid someone, right? Luciano?
I think so, and it's gonna be a surprise because I haven't prepared that. So stay tuned during the finishing song for the raid. Bye.